to resistance. We are not supposed to consider force is the function of uh, change in length, but that whatever the change which we are getting, that change is the function of resistance, because if your length is varying more, resistance change will be more. So that's why I have specified force is directly proportional to change in length. Okay, so this is wire strain gauge. Metallic strain gauge, common form. If you see the function, actually this part, external part I am specifying. This is the base. This is the base. Actual strain gauge, actual strain gauge, I would like to show you is this, this metallic part. These are the metallic part. This is nothing but this is your strain gauge. Okay, over here also, this is your strain gauge. And this part is the base which has been used to mount that strain gauge, which I am telling you people. Now, this one is a bounded type of metal foil. Now, what is the significance of bounded type? That has been specified over here. That has been specified over here. So here, if you more practical strain gauges, these are used for more practical. We people are having the setup also. So built out a thin layer of conducting material. If you see, this is the thin layer. This is the thin layer. What that has been built of a conducting. This one is conductive. This particular part is not conductive one, but the shining part or golden part is conductive one, conductive material deposited on an insulating substrate, deposited on an insulating substrate. So this base is nothing but it may be plastic, it may be ceramic or any other material that can be used to bound this aspect, to bound this aspect. Now the etching means you can have the entire material of this part, and even you can etch means you are applying some color and placing that one in a chemical. This will try to this will try to this particular aspect will try to this particular aspect will try to generate the resultant output after etching. By placing this part will remain, because this one was a printed, so it will remain as it is, but the else part, this upper part, this one or this part will be vanished by that particular chemical. That is the that process is called as a etching process. That process is called as a etching process. So deposit on a insulating substrate. So constant and 60%, that is copper. What material is that? Like a golden one. That is the mixture of a 60% copper and 40% nickel is most common material. As I have specified, afterwards you people will be able to tell the different material that has been used. Negligible temperature coefficient of the resistance. Okay, so other materials are also commonly used that I will tell you. So whatever I have explained, typical bounded one. What is this? This is the ceramic one. Now this one is the design parameter. This one is the design parameter. This is your gauge wire, felt. This is the backing. These are nothing but these are the leads. So over here, helical wire, different type. So when strain gauge is bounded to an object and the object changes in size, the resistance of the strain gauge will change, which we people are interested to have. So the resistance R is given by the expression. Resistance R is given by the expression. Okay, that the previous expression. I will not give that particular expression over here. So different composition of the strain gauge material, constant turns or advanced, isoelastic one, isoelastic two, karma. These are the different strain gauges. Then platinum tungsten. nichrome V, semiconductor strain gauge, and its gauge factor has been provided. So we people are interested to have the gauge factor. Increase in the gauge factor will increase the sensitivity, of the material, and the resultant output generated will be better with help of this particular aspect. Okay, so you can go through this composition, that 80% nickel, 20% chromium, 92% platinum, 8% wax. Okay, likewise material, ferrite or iron is used, aluminum is used, chromium is used, likewise material is used. So metallic strain gauge, common form. So strain gauge may also be used to measure multiple axes strain by simply using more than one gauge, or by producing them in a standard configuration. So how to mount that particular strain gauge? So if you try to observe this one, so this one is the x-axis, this one is the y-axis, 45-degree stack roasted. This is one type. Two-axis strain gauge. 120-degree. These are three strain gauges has been used. 45-degree roasted. This one, three. Likewise, you can mount over here. Member roasted. 45 degree. That has been collapsed on each other. Okay. Two axis, 120-degree roasted, 45-degree roasted, 45-degree stacked roasted means overlap on each other. Member roasted means many more strain gauges wounded like a circular mean. Likewise, you people can mount the strain gauge depending upon your application. Okay, these are the common forms that can be used for the various applications. So mounting part or implementing part can be covered over here. Okay. Now, in this particular aspect, so gauge length. Proper choice of gauge length is an important factor for some specific application. Strain is to be measured at the location where trace is maximum. The strain gauge average the measured strain over the gauge length. The measurement can be enormous to improper choice of the gauge length. So what are the factors they are associated with the gauge length that has been represented, over here, or the inputs has been given for the gauge length. Baking material. So what are the baking material? What are the factors to be taken under consideration? Why so? It electrically isolated the metallic gauge from the test specimen. It transmits the applied strain to the sensor. It provides the surface that is used for bonding the gauge with the surface where the strain is to be measured. The baking material should have wide temperature range, and polyimide and glass in reinforcement phenolic are two commonly used baking materials. The above one, it is electrically isolated the metallic gauge from the test specimen. This is one type of preservation. Then it transmit the applied strain, means that baking material should transmit the applied strain to the sensor. It should provide the surface that is used for the bonding gauge with the surface where strain is to be measured, and the baking material should have wide temperature range. If suppose temperature increase, your baking material should not have any impact on that one. So different baking material that can be used, that can sustain the above properties, are polyimide and glass reinforced phenolic. Okay. Now adhesive. So the bond, actually the connectivity between the baking material and the sensor that are supposed to be used. The bound created by the adhesive serves as a mechanical and thermal coupling between the strain gauge and the test specimen. So whatever the test specimen, that is nothing but if you try to, this is the specimen on which I am interested to mount the strain gauge. I am interested to mount the strain gauge that can be easily utilized. Okay, so adhesive is the material that can be incorporated. So bound created by the adhesive server as a mechanical and thermal coupling between the strain gauge and the test specimen. The adhesive should accurately transmit the given to the test specimen. It should have thermal conduction and expansion characteristics. Means this material characteristics we people are specifying adhesive material which is used. The adhesive should not shrink or expand during curing process. Otherwise,